As Al just mentioned, pretty favorable weather has allowed many farmers across Nebraska to get their planting completed. And part of your pre-planting regimen likely involved fertilizer nitrogen applications. But there might be some reasons to shift to a more in-season application. Extension Nutrient Management and Water Quality Specialist Javed Iqbal joined me this week to talk about it and give some tools to help you make your best informed decisions.
There are no set numbers for in-season versus pre-planned nitrogen application. However, if enough resources and equipment are available, we encourage that most of the recommended nitrogen be applied in season, especially before the crop rapidly starts to take up the nitrogen around V8 to V10 growth stage. So generally speaking, about 30 to 40% of the nitrogen can be applied as pre-planned, while the rest can be applied in season.
Let's move on to the late spring soil nitrate test. If you could explain how this can help producers with their nitrogen application decisions.
So there are many tools available that can help you to estimate and quantify the in-season nitrogen application. Late spring soil nitrate test is one of the tools where soil nitrate sampling is done in late spring to check the crop nitrogen availability. You can use this tool by collecting soil samples from 0 to 12 inches soil depth. When the corn is 6 to 12 inches tall, you can send that sample to soil testing lab and get results on soil nitrate nitrogen, and then you can compare these nitrogen values to the critical values those are used in this tool, and then this would help you to decide if you need to apply any nitrogen in season or how much nitrogen you need to apply in season.
And another important tool is remote sensing, also helpful for in-season nitrogen application. Explain to us how that works.
So remote sensing is actually one of the best options for estimating in-season nitrogen application. This canopy sensing technology actually considers actually uses crop canopy sensors. Those can be placed over the crop and can give you a status on crop nitrogen status. So when the healthy plants they are scanned, the healthy plants will reflect light in a different way than the stressed plants. The plants that are under stress are less than the optimal conditions. For example, Newton deficiencies will go through physiological changes, which will result in different spectral signatures. For example, stressed plants, they may read less infrared and more red edge than the healthy plants. So these differences would result into a greenness values, and crop canopy sensors can detect that greenness values, which can be translated through algorithm into the crop nitrogen needs. And then this approach actually is more reactive approach. And then this has the potential for maximizing nitrogen use efficiency while minimizing the nitrogen losses. Farmers, they can also use less nitrogen fertilizer for plants. Those are already getting enough nitrogen supply from the soil. So they can not only reduce the fertilizer amounts, but they can also reduce the nitrogen losses.